Hi, Kuya Junrey here. I want to tell you about magnets. We have known about the magnetic properties of certain types of matter for thousands of years and have long utilized this phenomenon for navigation in the form of a compass and also to display good report cards on the fridge. A few different kinds of magnets are instantly recognizable, like the popular horseshoe variety. The most people are aware that these attract iron-containing objects. Any bar magnet will have ends called poles. One will be the North Pole and one will be the South Pole, which were named as such because of the way a suspended bar magnet will orient with respect to the cardinal directions. This is how a compass works. It's just a magnetic needle that always points north. Like poles repel and opposite poles attract, just like electric charges. The difference is that opposite charges can be isolated, whereas no matter how many times you can cut a magnet in half, it will always contain both poles. To fully understand the properties of matter that allow for magnetic behavior, we must understand the electron configurations of the atoms in the magnet, and we must therefore learn some chemistry. But for our purposes here, it will suffice to understand that most materials contain atoms with all of their electrons paired up in orbitals with one spin up and one spin down, such that they cancel each other out, but some substances like iron, cobalt, and nickel have electrons that aren't cancelled out, and some of these can be called ferromagnetic. In these materials, the atoms will adopt an orientation such that all of their net spins are aligned in parallel fashion, and this phenomenon, which we can refer to as a magnetic domain, will generate a magnetic field. A magnetic field can be depicted using field lines just like an electric field. And though they will appear to begin at the North Pole of the magnet and end at the South Pole, they have no true ends. They are closed loops that continue through the magnet itself. In this way, Earth itself is a giant bar magnet with a magnetic North Pole about 1,500 kilometers from the geographic North Pole, and magnetic South Pole about the same distance from the geographic South Pole. The geographic poles mark Earth's axis of rotation, but the magnetic poles exist because of the way atoms are distributed in Earth's iron core, which align their spins just like the atoms in a bar magnet. The magnetic poles actually change their position slightly over thousands of years as material in the core changes position. There is so much magnetized material in the Earth's core that the magnetic field generated is absolutely immense, stretching far out into space. This field interacts with high-energy charged particles that race towards us from the sun and deflects them towards the magnetic poles to produce the aurora borealis when these particles collide with molecules in our atmosphere. They become excited and release colorful light upon relaxing back to the ground state. Without the Earth's magnetic field, we would be at tremendous risk from this kind of radiation, and life on Earth probably wouldn't be possible. Electric current is able to deflect a compass needle, and magnetic fields affect the paths of particles with electric charge, so it wasn't long until we realized that electricity and magnetism were two sides of the same coin, which was then dubbed the electromagnetic force. But it will be discussed later as our discussion continues. Remember that there are three kinds of magnets, and these are temporary magnets, the temporary ones, permanent magnets, which are objects made from a material that is magnetized and creates its own persistent magnetic field, and electromagnets that uses electricity. Again, A magnet is a material or object that produces a magnetic field. This magnetic field is invisible that is responsible for the most notable property of a magnet, a force that pulls on other ferromagnetic materials such as iron and attracts or repels other magnets.
Sumakay ako sa jeepney, ikaw ang katabi, di makapaniwala. Parang may hiwagang nadama, nagpagmama sa'yo aking mga mata. At nagsiksikan na dahil tumigil ang jeepney sa tapat ng eskwela. Biglang nagkadikit, puso ko'y biglang sumikip at natulala. Sabi nila'y walang hiwaga kung walay ano itong nagdadama. Ayoko nang pumarap kahit saan mapunta, ayoko nang pumarap kung ikaw ang kasama. Ayoko nang pumarap, ayoko nang pumarap, ayoko na. Ayoko nang pumarap kahit saan pa lumiko, ayoko nang pumarap, sana di na huminto. Ayoko nang pumarap, ayoko nang pumarap, ayoko na kung ikaw ang kasama.
The magnetic moment of a system measures the strength and the direction of its magnetism. The term itself usually refers to the magnetic dipole moment. Anything that is magnetic, like a bar magnet or a loop of electric current, has a magnetic moment. A magnetic moment is a vector quantity that has a magnitude and a direction. Magnetic materials are classified into diamagnetic, paramagnetic, and ferromagnetic based on their susceptibility. Magnetic susceptibility is the quantitative measure of the extent to which a material may be magnetized in relation to a given applied magnetic field. The magnetic susceptibility of a material is commonly symbolized by X of M. It is equal to the ratio of the magnetization M within the material to the applied magnetic field strength H, or X of M equals the magnetization over the applied magnetic field. This ratio is the susceptibility because magnetization essentially involves a certain measure of magnetism per unit volume. The first classification of the magnetic material is the diamagnetic. Diamagnetism is the property of an object or material that causes it to create a magnetic field in opposition to an externally applied magnetic field. Unlike paramagnets, diamagnets are repelled by magnetic fields, which can lead to its unusual effects such as levitation of diamagnetic material when located above powerful magnets. Diamagnetism is a fundamental property of all matter, although it is usually very weak. It is due to the non-cooperative behavior of orbiting electrons when exposed to an applied magnetic field. Diamagnetic substances are composed of atoms, which have no net magnetic moments. Most elements in the periodic table, including copper, silver, and gold, are diamagnetic. The second classification is the paramagnetic materials. Paramagnetism is a form of magnetism whereby the paramagnetic material is only attracted when in the presence of an externally applied magnetic field. Paramagnetic materials have a small positive susceptibility to magnetic fields. These materials are slightly attracted by a magnetic field, and the material does not retain the magnetic properties when the external field is removed. Paramagnetic materials include magnesium, molybdenum, lithium, and tantalum. Unlike ferromagnets, paramagnets do not retain any magnetization in the absence of an externally applied magnetic field. because thermal motion randomizes the spin orientations responsible for magnetism. Some paramagnetic materials retain spin disorder at absolute zero, meaning they are paramagnetic in the ground state. Thus, the total magnetization drops to zero when the applied field is removed. The third and the last classification of magnetic material is the ferromagnet. Ferromagnetism is the basic mechanism by which certain materials, such as iron, form permanent magnets or are attracted to magnets. Ferromagnetism is the strongest type. It is the only type that creates forces strong enough to be felt, and is responsible for the common phenomena of magnetism encountered in everyday life. Only certain materials such as iron, cobalt, nickel, and gadolinium exhibit strong magnetic effects. A group of materials made from the alloys of the rare earth elements are also used as strong and permanent magnets. Popular one is neodymium. Ferromagnetism is very important in industry and modern technology, and it is the basis for many electrical and electromechanical devices such as electromagnets, electric motors, generators, transformers, and magnetic storage like tape recorders and hard disks.
Through you, I can do anything. I can do all things. 'Cause it's you who gives me strength. Nothing is impossible. Through you, blind eyes are open. Strongholds are broken. I am living by faith. Nothing is impossible. Not gonna live by what I see. Not gonna live by what I feel. Deep down I know that you're here with me. I know that you can do anything. Come on, say. Through you I can do anything. I can do all things. 'Cause it's you who gives me strength. Nothing is impossible. Through you, blind eyes are open. Strongholds are broken. I am living by faith. Nothing is impossible.
So let's talk about electromagnetism. Electricity and magnetism are very closely related. The study of both and how they are connected is called electromagnetism. Electromagnetism is a branch of physics, deals with the electromagnetic force that occurs between electrically charged particles. The electromagnetic force is one of the four fundamental forces and exhibits electromagnetic fields such as magnetic fields, electric fields, and light. It is a basic reason electrons bound to the nucleus and responsible for the complete structure of the nucleus. One example of the interaction between electricity and magnetism is an electromagnet. An electromagnet is a special type of temporary magnet that only generates a magnetic field when electric current is flowing. This makes electromagnets very convenient because they can easily be turned on or off and can create very strong magnetic fields. Electromagnetism is a process where a magnetic field is created by introducing the current in the conductor. When a conductor is electrically charged, it generates magnetic lines and of force of conductor. Electromagnetism has two meanings, depending on whether viewed at subatomic level or on everyday scales. At the subatomic level, electromagnetism is defined as the force between electrically charged particles. It is considered one of the fundamental interactions of matter. Oscillating electrical charges results in electromagnetic waves. Electromagnetism is related to the electromagnetic force that causes the attractions and repulsion of electrically charged particles. It is considered one of the most fundamental forces on nature that also includes gravitational and nuclear forces. When electrically charged particles such as electrons are put into motion, they create a magnetic field. When these particles are made to oscillate, they create electromagnetic radiation. This can include radio waves, visible light, or X-rays, depending on the frequency of the oscillation. On a larger scale, electromagnetism is the creation of a magnetic field from the movement of electrical charges. It usually concerns the use of electric current to make electromagnetics, which is called electrodynamics. Another effect is electromagnetic induction, which is using an electromagnet or changing magnetic field to induce an electric current. Magnetism and electromagnetism are the fundamental concepts in physics. The main difference between magnetism and electromagnetism is that the term magnetism encompasses only phenomena due to magnetic forces, whereas electromagnetism encompasses phenomena due to both magnetic and electric forces. Electromagnetic force acts on objects that have electric charge. The electromagnetic force is carried by the photon and is responsible for atomic structure, chemical reactions, and attractive and repulsive forces associated with electrical charge and magnetism, and all other electromagnetic phenomena. While the electrostatics describe either being positive or negative charges, the objects with opposite charges produce an attractive force between them, while objects with the same charges produce a repulsive force. The greater the charge is, the greater the force, and the greater the distance between the charge of object, the smaller the force. And according to Coulomb's law, it is able to describe how photons in an atomic nucleus, which are positive, keep negatively charged electrons. And just like with the other fundamental forces of physics, there is a special particle that conveys this force. It is called photons. Photons carry the electrostatic force between the electron and the proton. Photons are the same particle that carry light and heat, which is why electromagnetic force is able to travel at the speed of light. While the electromagnetic waves are a form of energy waves that have both an electric and magnetic field, electromagnetic waves are different from mechanical waves in that they can transmit energy and travel through a vacuum. Electromagnetic waves are classified according to their frequency. The different types of waves have different uses and functions in our everyday lives. The most important of these is visible light, which enable us to see. And the electromagnetic radiation in a classical physics, it is the flow of energy at the universal speed of light through free space or through a material medium in the form of the electric and magnetic fields that make up electromagnetic waves such as radio waves, visible light, and gamma rays. And for the life application, we have example which is the permanent magnetic speakers, which is commonly used in TVs and radios, are the perfect example of electromagnetic devices. In order to convert electrical waves into audible sound, the speakers are designed. A metal coil is attached to a permanent magnet, and when current passes through the coil, it generates a magnetic field. The newly formed magnetic field is repelled by the permanent magnetic field, resulting in the vibrations. These vibrations are amplified by the cone-like structure, causing the sounds, and this is how speakers work based on electromagnetism.
Sumakay ako sa jeepney, ikaw ang katabi, di makapaniwala. Parang may hiwagang nadama na kumama sa'yo aking mga mata. At nagsiksik
electric charge. We live in the age where we take electricity for granted. But what is electricity made of? The discovery of a variety of phenomena over several centuries eventually led our mastery of this incredible power. Now, let's learn about it now. First, we know that there's such a thing as electric charge. The demonstration of this involved rubbing a balloon in your hair and seeing how the balloon attracts our hair shows some mysterious force. When the two balloons was rubbed in your hair, it will strangely push each other away. This happens because of electric charge, which displays by rubbing materials together. The hair becomes positively charged and the balloon becomes negatively charged, which this terminology developed by Benjamin Franklin. Opposite charges will attract one another, which is why your hair sticks to the balloon, and like charges repel with two balloons push each other away. This property of electric charge is carried by certain subatomic particles. The most common of these is proton, which are positively charged, and electron, which are negatively charged. Along with neutrons, they make up the atoms in the universe. As it happens, electrons, which are the essence of electricity, are easily to transfer. Through the terminology, the rubbing of the balloon in your hair, it generates electric charge in previously neutral materials. Each electron carries with it with a fundamental charge which is 1.6 times 10 raised to negative 19 coulomb. This magnitude is negative for the electron and positive to the proton. All substances will therefore have a charge that is some multiple of the amount, means electric charge is quantized. We can categorize some substance by their ability to transfer electric charge. A substance that can easily transfer electric charge is a conductor. One that can't is the insulator. Opposite charges attract one another because of the electric force. This is outlined in Coulomb's law, which states that the magnitude of the electric force between two objects is equal to the Coulomb's constant times the charge on one object and times the charge on the other, divided by the square of the distance between them. Remarkably, this is essentially identical to Newton's law of universal gravitation. The only difference with that is the electric force can be attractive or repulsive, depending on the sign of distance and resulting sign in the force, while gravity always attractive, and Coulomb's constant is greater than gravitational constant, illustrate the discrepancy in the strength of the z forces. This law also tells us that the electric force between two objects increases as charge increases and decreases as distance between them increases. If more than two charges are present, vector addition must be done to find out the net force upon any particle in the system, just as a gravitational field is what allows the gravitational force to propagate. It is an electric field was allow electric force to propagate. However, as we said, the electric force is much stronger than gravity. This is evidence to find the fact that the repulsion between particles in your feet and the particles on the ground is more than strong enough to keep you from plummeting on the center of the earth. We can also use the little cheap refrigerator magnet to keep a piece of paper in the fridge against the gravitational force on the entire planet. Any charged object can manifest any electric field, which will be discussed by Therese Mungcal.
The example problem for electric charge is: what is the force between two small charged spheres having charges of 2 times 10 raised to negative 7 coulomb and 3 times 10 raised to negative 7 coulomb placed 30 centimeter apart in air? The formula for this is
force between the charges as equal to Coulomb constant times the charge on the first object and times to the other object, divided by the square of the distance between them. Now, we write the distance as 0.3 meter conversion to from 30 centimeter to meter, which is equal to 0.3 meter. Now, first, let's write the Coulomb constant, which is 9 times 10 raised to 9, which is multiply to the first object, which is 2 times 10 raised to negative 7, multiply to the other object, which is 3 times 10 raised to negative 7, and divided to 0.3 meter, which we will write is as 3 times 10 raised to negative 1 squared. We wrote that distance for simplification. Now, first, the 3 squared is equal to 9, so it will be cancelled like this. Then, the next step is multiply 2 and 3, which is 6. Then 10 times 10, which is negative 7 plus negative 7 is equal to 14 minus to 9, which is equal to 10 raised to negative 5. Then divided to 10 raised to negative 2, which is equal to negative 3 Newton. That is the force. So it means the two objects are repulsive. The direction of this is, it is away from each other. They are not attractive. They are repulsive.
Through you, I can do anything. I can do all things. 'Cause it's you who gives me strength. Nothing is impossible. Through you, blind eyes are open. Strongholds are broken. I am there.
Last time, we talked about how charged particles exert electrostatic forces on one another. We calculate these forces using the charge of each particle, which could be positive or negative, and the distance between them. But when we talk about more than two charges or with dealing charged object, various shapes and sizes, Coulomb's law are great for finding the force between small objects like particles. But in physics, we do with all the shapes and sizes electric forces are used to bring in power to your home, charger, computer, and lights of the screen that you are using to watching videos because of the equation and concepts under about already, but we need to few more standing on how to control the charged particles and expand the possibilities on electricity. So, we want to describe the complex situation involving charged particles using more than just Coulomb's law. He had proposed that every charged object generates electric fields that dominate space and exerts the force on all charged particles that encountered. The field carries energy impulses on the other charged materials by exerting electric forces, and we can get to know on how electric force will work in different ways. One way we depict electric field is by drawing electric field lines which generally point towards negative charges and away from the positive charges and do not cross these don't really exist. They are the convenient way to analyze the direction of a field at any point of space, like the field produced by this opposite charge particle, which we can call an electric dipole. The more densely packed to the field of lines are in particularly region, the greater the strength of the field. And now, some example created by electric dipole, because along the way I'm gonna show the important properties of electric field lines. This means when we replace a positive test charge anyway, the field lines opponent the direction of the force exerted on the positive test charge. It also means that the negative charge will field force in exact opposite direction. As a test charge may closely to the one of the fixed charges, the forces under will be larger, thus the great number of lines in that area. And there are no negatively charged object around them, then the lines keep going forever into infinity, seeking out negatively charged objects wherever they can find them in electric dipole. The lines start in positively charged particle and move towards a negatively charged one, and the same number of lines come out in each particle because the magnitude of the charges are equal. Crisscrossing lines means the field act in different direction in that same direction, which is impossible. And now, we know how to build electric field lines based on the set of protege objects. Let's do the reverse in setup of an object to achieve the second purpose. Let's now how to create electric field that all positive test charges move uniformly in a single direction. And since the electric field represents the electric forces up on the nearby charges when the net force is zero, the electric field will be zero. These conditions hold true for all conductive materials. While the electric put inside the material is zero, then the electric put exists outside the surface of the conductor. Let's look again the capacitor, see what I mean. Now, what if we take the neutral conductive shape, hold all out the inside and stick the positively charged particle in the center? Once the system is in electrostatic equilibrium, the observations will remain before still hold true, the charges stop moving, so no electric field exists inside the shell. Any positive test charge in a region will further field line will be pushed to the negative interior of the shell. So, I had mentioned to you they all know of electric field. To figure it out, the way to describe the effect of any charged object in the entire universe around again. How do we find the relation between those two? For that, we use this linear charge density and multiply the length we get the charge on there. Therefore, we can write dq is equal to linear dx. And now let's do a line for the segment to the point of interest. And we said for this is r, and of course r is related to x and a using Pythagorean theorem. And now we can say that the electric field experienced at this location due to this small segment right there is going to be a small arrow of magnitude of dE. We can say dE is equal to k dq over r squared from the location to the charge that causes square. Since r dq is equal to linear dx, we can write k over x squared. That is the magnitude of the electric field at that location up to the small charge. Now, we can use Gauss Law, and I believe I do have to find the electric field location using Gauss Law. Now, I notice we have here horizontal component and vertical component. Dapat na lang na Junrey. Asan na ba tayo? Ito na lang sa now we can use Gauss Law. Ito na lang.
Sige na. Go na.
Nagsisimula ka na ba?
Oo,
Ay,
kaya
joke lang.
hindi ko siya kinat.
Now we can use Gauss Law, and I believe I do have to find electric field location using Gauss Law. Now I notice we have here a horizontal and component and vertical component, and this would be a dE in x direction and dE in y direction. Because in every lost segment, as I go and move and over, we can say that we have horizontal and vertical component. But also, we have a line segment on the other side. And we start building a line segment and find electric field to the line charge. And I notice it also have vertical and horizontal component. And we called it dE, and notice that in the same number of segments below this point, and this will be above the point, the vertical component cancel out, and it still remain the horizontal component. And we figure it out that we have to find out the dE sub x component. And we have a theta in an equal right here. And to find the dE sub x component, we can say that dE x is equal to dE cosine theta. Then we can say is equal to k linear dx over x squared plus a squared. And now, what is the cosine theta here? I've noticed is keep drawing this way, and this here is the opposite side of this angle, and here is the adjacent side in this angle and the hypotenuse. Since the cosine of theta is adjacent and over hypotenuse, A will be an adjacent, and R can be written as hypotenuse. So we can replace this cosine by this in our equation. Times dx. We have the x component of electric field of our infinite line segment, and to find the total of dE of x, we simply add all these in the total of E of x is equal to the sum of all the component that we get each segment right there. And that would be equal to the integral all of k times linear times a times dx divided by x squared plus a squared 3 halves. By integrating that in this location, move into the positive infinity, and this one is move into the negative infinity, so we can go from negative theta to positive theta. And I realized that a, k, and linear are a constant. So that we have a E sub x is equal to k times linear times a integral of theta negative theta dx over x squared plus a squared 3 halves. And we simplify, simplify k times linear times a x a squared 1/2 cancel out a negative 8 is equal to k times linear, and we substitute theta squared plus a squared over 1/2 minus negative plus a squared over 1/2 is equal to k over a 1 plus 1, and that is the magnitude, and this would be the magnitude of that x. Okay. and that is the magnitude of that, and it would be the total of electric field in this location, and the vector is look like this: twice of constant k times the linear charge density divided by the distance away from that line, and that's the way to find electric field of the infinite line of charge.
Sumakay ako sa jeepney, ikaw ang katabi, di makapaniwala. Parang may hiwagang nadama na kumama sa'yo ang aking mga mata. At nagsiksikan na dahil tumigil ang jeepney sa tapat ng eskwela. Biglang nagkadikit, puso ko'y biglang sumikip at natulala. Sabi nila'y walang hiwaga kung walay ano itong nagdadama. Ayoko nang pumarap kahit saan mapunta. Ayoko nang pumarap kung ikaw ang kasama. Ayoko nang pumarap, ayoko nang pumarap, ayoko na. Ayoko nang pumarap kahit saan palumiko. Ayoko nang pumarap, sana di na huminto. Ayoko nang pumarap, ayoko nang pumarap, ayoko na kung ikaw ang kasama.
Gauss Law states that the total electric flux out of a closed surface is equal to the charge enclosed divided by the permittivity. The electric flux in an area is defined as the electric field multiplied by the area of the surface, projected in a plane and perpendicular to the field. The total flux linked with the closed surface is 1 over permittivity of free space times the charge enclosed with the closed surface. For example, a point charge is placed inside the cube of edge. Now, as per Gauss law, the flux through each face of the cube is Q over 6 permittivity. The electric field is the basic concept to know about electricity. Generally, the electric field of the surface is calculated by applying Coulomb's law. But to calculate the electric field distribution in a closed surface, we need to understand the concept of the Gauss law. It explains about the electric charge enclosed in the closed or the electric charge present in the closed surface. As per the Gauss theorem, the total charge enclosed in a closed surface is proportional to the total flux. And as enclosed with the surface, therefore, if the total flux and permittivity is electric constant, the total electric charge Q enclosed by the surface is Q is equal to the electric constant. The Gauss law formula is expressed by the total charge over the electric constant. Okay, for the next example, we have the Gauss law example. And we have here the sphere with the radius A, and we're going to find the electric field outside the surface. Here we call this the Gaussian surface with the radius R. And since the Gauss law states that the flux of the surface E dot dA is equal to 1 over the permittivity times the total charge enclosed. This is the charge enclosed. And since the direction of the radius is the same, we can say that the integral of E vector times the dA vector is equal to the magnitude of E times the magnitude of that area. And since E is constant, we will put this outside the integral sign. Then we have the E integral dA, and the area of the surface is 4 pi r squared, and we have the E 4 pi r squared. Since we will find the electric field outside the surface, we will put E on the left side, and we're going to execute some algebra functions, and we have the 1 over pi r squared and Q over the permittivity. Since it is positive charge, we're going to put R here. That's all.
Sumakay ako sa jeepney, ikaw ang katabi, di makapaniwala. Parang may hiwagang nadama na kumama sa'yo ang aking mga mata. At nagsiksikan na dahil tumigil ang jeepney sa tapat ng eskwela. Biglang nagkadikit, puso ko'y biglang sumikip at natulala. Sabi nila'y walang hiwaga kung wala'y ano itong nagdadama. Ayoko nang pumarap kahit saan mapunta. Ayoko nang pumarap kung ikaw ang kasama. Ayoko nang pumarap, ayoko nang pumarap, ayoko na. Ayoko nang pumarap kahit saan pa lumiko. Ayoko nang pumarap, sana di na huminto. Ayoko nang pumarap, ayoko nang pumarap, ayoko na kung ikaw ang kasama.
Hi, sir!
Marami pong salamat sa mga ituro niyo sa amin. Hindi lang sa ACADS, pati na din sa mga lessons sa buhay. Salamat din sa materyang patuturo. Humahanga po ako sa way niyo ng pagtuturo na parang sanay na kayo sa subject. Sa loob ng isang SEM, ilang adjustments na po yung nagawa ninyo at ilang bonus points na yung ibigay ninyo sa amin. Ginagawa niyo yung paraan makapasa lang kami na hindi dinadaan sa madaling paraan. Madaming bagay din na natutunan ko sa inyo. Isa na dito yung hindi natin kailangang habulin ng isang bagay kung hindi naman ito para sa atin. May mga alternatibo naman na pwedeng ipalit at matutong humanap ng ibang paraan dahil hindi lahat ng kayang ituro ng instructor sa loob ng ilang oras lamang. Hindi matutumbasan ng kahit anong salita o pasasalamat ng mga pagod at hirap nyo sa section namin.
Again, thank you sa lahat ng lessons na naituro niyo sa amin. Thank you ulit!
Hi sir! Yan, patapos na naman po ang SEM na ito. Sobrang dami po namin bagay natutunan mula pa po first SEM. Kahit na po, thank you po kasi kahit na ang hirap ng mga topics, ang hirap ng subject is pinipilit nyo pa rin po ipa-cope up sa amin. Yung ginagawa nyo po talagang best para mapaturo sa amin yung mga lesson at para maintindihan namin. Thank you po at hindi ko po makakalimutan yung UP mantra na sinabi nyo sa amin na honor before excellence na tsaka thank you din po sa pag-i-inspire sa amin na kahit na feeling namin babagsak na kami, pinupush nyo pa rin po kami na gawin namin yung best namin para makapasa at mas-survive tong SEM na to. Thank you sir, sobrang dami po thank you sa lahat ng bagay na ginawa nyo, mga lesson in life na tinuro nyo. Thank you sir, God bless you.
Hi sir! Thank you po sa lahat-lahat.
Sir Chongson, thank you po sa pag-inspire sa amin sa aming pag-aaral at sa aming araw-araw na pamumuhay. Salamat po sa mga turo ninyo at sa mga aral na tinuro nyo sa amin tuwing tayo po ay nagdi-discuss kahit sa lesson man or
para sa buhay man. Nagpapasalamat po ako dahil naging malaking tulong po yun para sa akin. At para din po yun sa aking mga kaklase. Napakabuti nyo po dahil nai-inspire nyo po kami at sana po sa pagdating pa po ng madaming panahon at sa susunod pa pong mga estudyante ninyo ay mas lalo mo po silang ma-inspire katulad po naming mga na-inspire nyo po. Nagpapasalamat po kami na sa lahat ng pagtitiis kahit na sobrang ingay namin, kahit na minsan hindi na po namin maintindihan yung tinuturo nyo, ay mas nagagawa pa rin po namin maintindihan dahil po sa kagalingan nyo po sa pagtuturo sa amin. Kaya sana po ay maging mas madami pa po kayong maituro sa susunod pang mga estudyante, hindi lang po sa amin. Thank you, Sir Chongson. Sana po ay palagi po kayong mag-iingat at sana din po ay lagi nyo pong iisipin na nandiyan lang po palagi sa ating tabi si Lord. Basta lagi lang po natin siyang tatawagin at kakausapin. Hinihintay lang po niya lagi tayo. Thank you, Sir Chongson, for everything. Alam po namin na madami po kayong pinoproblema sa buhay. Alam ko pong kaya niyo po yun. Thank you.
Sir, inuulit ko po, thank you po sa lahat-lahat. We love you so much. God bless you always.
Hi, sir. Sorry po sa lahat po ng mga nagawa namin kasalanan, pagiging makulit po, at pagiging maingay po sa loob po ng classroom. Pero nagpapasalamat po ako sa lahat po ng pagsakripisyo nyo po sa amin, sa lahat po ng pagtuturo po ng mga lectures na kailangan po namin matutunan sa physics po. Maraming salamat rin po sa pagiging mapagkumbaba po sa lahat po ng bagay. So, yun lamang po. God bless po.
Hello po, sir. Thank you po sa lahat. Thank you po sa lahat ng mga itinuro nyo, sa lahat po ng life lessons, sa lahat po. Sa lahat po ng pag-aalaga nyo sa amin, pagtatyaga po sa pagtuturo. Alam po namin na hindi po ganun kadali ang magturo and alam po namin na pinagsusumikapan nyo po para ibigay yung best nyo sa amin. And alam din po namin na lahat po ng time nyo ay nilalaan nyo sa pagtuturo upang mabigyan po kami ng maayos na at kalidad na knowledge. And thank you po doon para sa lahat. And thank you din po dahil nandyan po kayo kapag kailangan. Again po, thank you po sa lahat and God bless po.
Hi, sir!
Sir, the most important things you ever taught of us weren't the lessons about the class material, but the lessons about life that you taught. You have been a great mentor and a role model not just to me but to all the students of PSIE 1201. You have and will continue to be a great influence on us. Thank you for the great work you do and the huge impact you make in young people's lives as a teacher. I learned a lot in your class because you took the extra time to explain things clearly. You gave us the extra help we needed. Thank you for giving us your time. The best thing about having you as a teacher is that we'll benefit from what we've learned from the rest of our lives. You've given us knowledge and skills for life. If all teachers were like you, there would be no child left behind.
Again, thank you po sa lahat and God bless you always po.